So we're going to be talking about trees. We're going to talk about trees generally, and we're going to talk about binary trees specifically going forward. So the first part of this lecture is going to be a lot of terminology and definitions until we can get things set up. From there, we're going to talk about nodes and generic trees and the abstract data type of a tree. And then we're going to spend most of our time dealing with binary trees and including things like recursion and traversal algorithms. These are going to be some big elements to talk about in this chapter. Recursion trips people up. It's a confusing idea for a lot of people until you get used to it, and then it's pretty useful. And honestly, you end up thinking that way more than you should. So, what is a tree? What is a tree? So I don't see a bunch of people jumping in. So for those of you who are in discrete math, you might have already come across this term. A tree is an acyclic graph. We won't get into graphs in this class, but you will get into them significantly in data structures, probably in algorithms. And then if you end up taking any classes like AI, graphs are very important data types and data structures that represent relationships. So a tree can be considered an acyclic graph, or we could think of it as a hierarchical data structure that's nonlinear in nature, right? So it's not like a linked list. It's not like an array. It is hierarchical. Things come at higher levels and more generically than others. We could also think of it as this thing, right? Trees are frequently used to represent concepts, to represent organizational structures, right? And at higher levels up here, you tend to be more generic. And then as you move down, you get more and more specific. So entertainment can be broken out into podcasts, TV, and movies. TV can be broken out into different TV shows like MASH or Schitt's Creek. Movies could be broken out into Captain America or Harry Potter or Mother, or I know you guys are all big Darren Aronofsky fans. And Captain America could then be broken down into the First Avenger or Winter Soldier. So all of these nodes are hierarchical and sort of fractal. And we'll get into what that means in a minute. So let's get into some basic definitions. What is a node? When we're talking about a tree and we're talking about nodes, what is that? A point on a tree, right? Yeah, good. It's an element in the tree. Each of these things is a node, right? It represents some aspect in the tree. What about an edge? When we're talking about edges in trees, what do they represent? What are they doing? What do they show? Yeah, the relationship, specifically, what kind of relationship? Parent-child, exactly. So that's all this is. Movie is parent to Captain America. Captain America is child of movie. Right? We talked about this with the quiz, root, right? The root, node with no parents, ancestor of all nodes. All nodes are descended from it. Right? So this is good. And a leaf is the opposite, node with no children. So in this tree, what's the root node? Yeah. Entertainment, good. What are, you don't have to name them all. Or how many leaf nodes are there? I'll give you either option. Or both options, I don't care. I'm feeling Gigi. Yeah, 5, good. All right, this is good. And we can see it's Radiolab, it's MASH, it's Schitt's Creek, it's First Avenger, and it's Winter Soldier. They're not at the same level, and they don't have to be at the same level. And we'll talk about levels more in a moment, like say now, right? Well, actually, we'll talk about degrees first. So degree, does anyone know what the degree of a node is? That's okay. This isn't super highlighted, and it's going to become less important as we get into binary trees because it's the number of children a node has, right? So all leaf nodes are degree 0. Podcast is degree 1. Captain America is degree 2, right? Entertainment is degree 3. We don't care about how many parents they have, though. Why? Because how many parents does every node have? 1. Good. Yeah, except for the root, which has 0. And this guy's got 0. Everyone else is 1. So we don't really care about that relationship specifically in a numeric sense, in a quantified sense, specifically because we already know the answer. Okay. Siblings. What do we think sibling nodes are? Nodes with the same parent, right? You'll see that while this is not going to be a great diagram for a family tree, that there's going to be a lot of familial relationships, right? Entertainment could be called a grandparent of MASH or a grandparent of Captain America, right? MASH and Schitt's Creek are siblings. First Avenger and Winter Soldier are siblings. We typically only talk about parent-child relationships, but sibling relationships do come in handy at certain points. But there's nothing to prevent you from talking about like aunt-uncle relationships, right? Schitt's Creek in movies, right? You could consider that a aunt or uncle relationship because it's the sibling of the parent. That's not real common, but that's not an inappropriate terminology to use, right? You're going to see a lot of familial terminology in these relationships. What's a subtree? So I hope the silence is because you guys are bored or not here and not because you're confused, because this is going to be a really big concept. A subtree is a tree created from a node and all of its descendants. So if you grab movies here, right, and you say, I'm going to create a subtree from movies, it would be movies, Captain America, First Avenger, and Winter Soldier. Okay. That thing that I circled, is that a valid tree? Yeah. Right? What's the root of the tree? Movies. Right? So when I said earlier that trees are fractal data structures, do we know what a fractal is, by the way? Yeah, it's a non-ending, repeating structure, right? It's a mathematical concept, and I am doing a great disservice to it by being so casual with the definition. But it's an idea that any aspect, any sub-aspect of the pattern is fully representative of the pattern. And this is true here. Dividing this guy up, dividing any tree up based on a root and all of its descendants, a node and all of its descendants, creates a full tree in and of itself. And we could have something above entertainment, right? This could be a subtree of a larger tree. We'd never know. And that's okay. So this is a key concept here. This one is a big one and is going to get into the concept of recursion, because these subtree patterns and recursion are really handy and do go hand in hand. When we talk about a path within a tree, what are we talking about? Okay, you're on the right path, lol. You're on the right track there, but it's not just from parent to child, right? It's between any two nodes. It's a sequence of nodes to get from one node to another, and we're going to typically talk about paths from the root, right, to a leaf, or from a node to a to a descendant. But we might also talk about it from one node up the tree and then down to another, right? So the path from Radiolab to Winter Soldier is Radiolab, Podcasts, Entertainment, Movie, Captain America, Winter Soldier. That is absolutely a valid path. Few more definitions that we need to get out of the way before we can get into the fun stuff, air quotes fun stuff. We need to talk about levels or depth of nodes in a tree, right? And we hinted at this a little bit already, right? Level or depth is how far into a tree a node is, right? So level or depth deals with the nodes. So you got to remember that our root is at level 0 or a depth of 0, and then each edge that you traverse from the root to that node takes you down one level, or one level deeper into the tree. Right, so you can see that the 2 Captain America movies are at level 3. Podcast, TV, and movies are at level 1. How is this different than height? Okay, so this is tricky. The difference is within these two concepts, right? The height of a node, or the height of a tree in general, is the number of nodes. Whereas the level or depth, okay, yeah, it's how far down from the root node it is, but really we're counting these edges, right? So what is the height of this tree and why? How'd you get 6? Where'd you get the 6 from? Okay, so remember, from the root to a leaf. So that's good, what you did there. So we're going, right, entertainment, movies, Captain America, and then either First Avenger or Winter Soldier. Either of those is 4. We have a height of 4. How many edges do we traverse to get from entertainment to either of those? And that's the difference, right? 1, 2, 3, right? So our max depth is 3, but our height is 4. The maximum depth of your tree is always going to be 1 minus your height, okay? When we talk about depth, we're talking about a given node. When we're talking about height, we are generally talking about the tree in general, right? How tall is that tree? What's the height of that tree, right? We don't really talk about, hey, what's the height of that branch? That's not usually a thing that we talk about when we look at trees, you know, actual physical trees made of wood. So this is it. Like if we have this, right, and we can talk about branches, right? This is another concept, right? The subtree down a given edge is a branch of a tree. That is a term that I did not mention, but is also a valid term that we should talk about, different branches of trees. But once we have these written down, once we know what these terms are, we can start to talk about trees generally speaking.